Okay, so what makes a pyramid?
Triangles.
Something about triangles.
One base.
One base that's made of a
Polygon.
any old polygon you want. So it has one polygon base
And an apex.
and then triangular faces. Okay. How many faces is it going to have?
Oh wait.
Well, the lateral ones will always be the same as however many sides the base has. And then the total faces, you always add one to count the base face. That was all the stuff we did at the end of last one. We had to keep straight, oh yeah, if this is a square, I'll have 4 triangles meeting up at the top, plus one base, 5 faces altogether. Now the vertex of a pyramid, there's more than one vertex, isn't there? There's a whole bunch of them. So guess what this is really talking about? Guess what this point at the top is? That's your apex. Okay? And yeah, some people call it just the vertex of the pyramid, but it's like there's more than one vertex there, so we're going to call that the apex. It's the common vertex where all the triangular faces meet. So all the points of all those triangles has to come up to one spot. That's your apex. So, candy to someone who thinks they can tell me, what would a regular pyramid be? What do you think?
A pyramid.
It's a pyramid.
With congruent faces.
No. They do end up being congruent, but that's not the definition.
A pyramid with a regular polygon as its base.
Yeah, its base is a regular polygon. So it will end up making the faces be congruent. So I'll go get candy for that too. Pyramid with a regular polygon for the base. And to be a regular polygon, in order for those side face triangles to be congruent, the apex is going to be perpendicular above the center of the base. Okay, so if you were to take this and drew perpendicular straight down to the base, that's going to make it be a right regular pyramid. And all of ours are going to be nice and regular, because if it's regular, then what's going to be true about all these triangles? If it's regular and it's right, all of these triangles, all these faces, are going to be the same size. So this one is the same as this one, is the same as this one. But only if it's going straight up and down. If the point was over here, would they all be congruent? No. So it's all got to be straight up and down. Okay? And so we've got, let's see, this picture here, what's the big B stand for?
Area of base.
Area of base. Area of the base. What's the P stand for? Perimeter. So perimeter of what?
Base.
Perimeter of the base. Big B was area of base. What is this little guy? This little curly looking dude.
Slight height.
Okay, it's called the slant height. What's the slant height? Describe. It's pointing to this right here. Okay, what do you think?
The lateral distance between the side of the base and the apex.
Yeah, let's keep it simple. That slant height is just the height of a triangular face. It's just that perpendicular height down the middle of the face. So slant height is the height of the triangular face of a pyramid. And if it's a nice regular right pyramid, they should all be the same. But but wait a minute. That slant heights are always what? Perpendicular. That height is perpendicular to that edge of the pyramid, isn't it?
Yes.
Making that
Which makes what kind of triangle with this edge of the pyramid?
Right.
Makes a right triangle. Now, is it a special right? We don't know. It could be, so then you might get to use those, or you might get to use trig, or you might get to use Pythagorean theorem.
I take it.
All this stuff you were afraid, I told you back in October that you would not escape triangles for the rest of the year. I did not lie, did I? Oh, and I've been working on making the final, and yeah, this is on the final. You're welcome. I love you guys. Why the heck is slant height represented with a lowercase cursive L?
Because it's different than length.
confused as length.
Yeah, well, because we don't want to confuse it with the up and down height, do we? This vertical height from your apex down to the center, that's H. So we don't want to confuse it with that one, so we definitely don't want to use H for slant height. Why don't we use S?
Why do we do
That's
side?
side.
The S, well, S could be a side of an edge, but also, and a big S might look like a 5. We don't want that. Okay? And then, so we've got, why do we use a cursive L? Why do we use an L at all?
That's a good question.
What do you think?
Lateral distance.
You could think it's the lateral height, but that doesn't match any of your words here.
That is true.
We want something that's part of the word. We can't use the S because S is for side. So guess what the next letter is? L.
Oh.
The second letter in slant is L. And why did we use cursive L and not regular lowercase l?
It's definitely right.
Uh-huh. Well, lowercase l's look like, well, first of all, length, but
It's
also,
slanted.
no, because a lowercase l looks like a 1.
Oh. Well, also, cursive L is slanted.
And so we use a cursive L for slant height, because it's the second letter of slant. Hey guys, I'm teaching.
I thought I was being confused.
Okay. But then what the heck is this?
A slant height.
Hey guys.
This is an italic L. So that if you're not doing if you're not in a font that does cursive, that italic L can be used in place of your cursive L, okay, for your slant height. And so now you're ready to get your formula for the surface area of a pyramid, because you have now figured out all the letters that are in it. Now, if I want to find the total surface area of this pyramid, I have flattened it out. What's the first area I should find? The area of this base, okay? And so, so if I'm going to do surface area, I'm going to need the area of the base. That's big B. What else am I going to need to find areas of? The triangles. How do I get the area of a triangle? 1/2 base times the height. Well, this height is what on my pyramid?
That's
That's my slant height.
Oh my gosh.
So I'm going to need my slant height, and I'm going to need 1/2. Now, the question is, do you want to have to find each triangle individually?
no.
No, because you're lazy. So instead of doing base times height divided by 2, base times height divided by 2, base times height divided by 2, what if we just added all of those together? Well, what would all these bases added together make?
Perimeter of base.
The perimeter. And there is your formula for the surface area of a pyramid. The 1/2 perimeter slant height gives you all the triangle faces. And the area of the base gives you the area of the base. And so together, that gives you everything you want for your entire surface area. Okay? So, yay! You got all your different pieces. Okay? And so then we get to have even more fun and go, okay, what if I swap out my polygon on the bottom for a circle? Is it a polyhedron anymore? No. So do we get to call it a pyramid anymore?
No.
No. What are you stuck calling it?
Cone.
It's a cone. Okay? So a cone is a 3D solid with a circular base and, let's see, a vertex at the top called the apex. And it has a lot of the same pieces that your pyramid did, okay? It has a surface around the outside. It's just called your lateral surface, since it's not really a semicircle, it's not really a triangle, and so we just call it the lateral surface, is this whole outside part of the pyramid, okay? But it still has a slant height, which is what letter? Cursive L or italicized L. It still has a perpendicular height, which is just called your height, H. But now, if you wanted to find the perimeter, you would really be finding the circumference of a circle, and to find the area and stuff, everything would involve this radius instead, okay? And so a right cone is just a cone where the vertex is perpendicular above the center of the circle. And so we're going to pretty much stick with right cones. But you're going to see here that my vertex is perpendicular above the center of that circle. Okay? So does anybody want to guess the formula for surface area of a cone, since cones are so much like pyramids? What do you think?
1/2 PL plus B.
1/2 perimeter times L plus B. But I'm not going to put P, because what makes the perimeter of a circle? Circumference. So I'll just put C. Could you put P, though? Yes, and in fact, when you look on the board over there in the center, you're going to see that I just put the 1/2 PL plus B. And you can just know that perimeter of a circle is called circumference.
With circumference, the uppercase C or lowercase c?
Uppercase C.
Okay.
But wait, how do you get circumference of a circle?
2 bar.
2 pi r. So you would have to do formula inception. When you did this, you would have to calculate your circumference using 2 pi r and put it in there. What's this L again? Slant height. Do you think I'm always going to give you the slant height? No. Because look, the slant height is this lovely slant. But your regular height is perpendicular to the radius going out to that slant. Doesn't that make a lovely right triangle? Because I've got my height down the center of my cone, my slant height, and then the radius. That makes a right triangle. And so you can use Pythagorean theorem, or trig, or special rights. If I gave you the height and the radius, you could calculate the slant height. See, we don't want you to get bored. You know, we give you stuff to do. Got to think a little. And then how am I going to find big B in a cone? How am I going to find that? What's big B?
Area.
Area of base. So how do I find that for a cone? pi r squared, even though they're round. But your formulas are basically the same thing. This formula on top works for anything remotely like a pyramid, including a cone. You just have to keep straight that a perimeter is a circumference in a circle. Okay? Turn the page. Because that was still just area. That's still just area. What does area measure? Squares. Area measures squares. But what does volume measure? Cubes. Now we're really getting 3D here.
Now I'm really hungry.
Okay? And so, if I want to do the volume of a pyramid, I'm trying to figure out how many cubes could fill this whole space. And so, to figure that out, we're going to do a little fun stuff, and those on the video are just going to have to listen and not get to see. So I'm going to show you, here is a prism, and here is a pyramid that have exactly the same base. Okay? What shape is the base? It's a square. They both have square bases. And this pyramid is going to be the same height as the base. My question to you is, do they have the same volume?
No.
Which one do you think has more volume? The prism? You think this prism has more volume than this pyramid? Well, I'm kind of inclined to agree with you, because it definitely doesn't fill it all the way up. What I want to know is there a relationship between those two? And so what I'm going to do is we're going to play with water.
Oh.
So let's see. Here is a triangular prism and a triangular pyramid. You will see that, behold, they have the same shape and size of base. And behold, they have the same perpendicular height. Will they have the same volume?
No.
I need a victim volunteer to come up and see how many pyramids it takes to fill up the prism. And Alana had her hand up real fast. So what I want you to do is fill up this pyramid with water and pour it into the prism. You might want to come around here because they don't want to be just staring at your butt. I've got to fill it up all the way.
Not both.
So we took one pyramid, at least. Keep going. We got to see how many it takes. What do you think? It's going to take 4? 3? 3? 5?
Not full yet.
Not full yet?
You have 3 on that side, so I'm going to say it's going to take 3.
It took 3?
Mm-hmm.
Okay, sort out.
Good
job,
Good job. So get Amy.
Thank you.
Good job, Lovey.
So how much of the prism did the pyramid fill up?
1/3.
It filled up 1/3. Oh, but maybe that only works because they were triangles. Should we test and see if it works for any shape base?
Yes, we
Yes.
should.
Okay, so here I have a pyramid and a prism that have square bases and have the same height. Okay, so let's see if now that it has 4 sides, maybe it's a quarter. So do I have a victim? Hey Maggie, you were pretty quick on this one.
Go, Maggie.
See how many of these pyramids, if they're square on the bottom, will fill it up. No pressure, don't spill anything.
We got one.
We got one. Do you think that's a quarter? Half? Third? 2?
2.
And 3. Well done. So is the pyramid how much of the prism?
A third.
A third. What about if they were round?
It's still going to be 30.
If they have the same base and the same height. Do you think it's still a third?
Yeah.
Anybody want to try it just for giggles? Oh, so many people are wanting to do this.
Miss Serena, please.
Okay, Vincent.
Yes, Vincent.
The people in the back miss out on so much. We got to give them all a chance. No pressure, everybody's serious. Working on his career as a bartender.
I'd take that.
Don't talk about that.
Three? All right. All right. So, now that you know the relationship, do I need to make a whole new formula then? No. All I can do is say that the volume of a pyramid is just the volume of the prism, or a third the volume of a prism. Well, how do you get the volume of a prism? Area of base times the height. Why is it 1/3? I could prove it to you, but it would take forever and I'm lazy. So you're just going to have to wonder. Okay? What about for a cone? Same. He proved it. It's the same formula. You just do whatever the prism formula was times a third. Okay? But be careful. This height, okay, is this perpendicular height down the center. Okay? It's not the same as your slant height going down the side of your cone or your pyramid. Those are different. And your brain is going to want to jump to using one or the other automatically. Just always make sure you're using the right height in the right spot. Okay? Well, cool. Let's go crazy. Let's get completely away from anything flat. Let's go to a sphere. Oh, yeah. What's a sphere?
It's
I circle.
No, it is not a circle. A circle, hey, a circle is all the points in a plane that are the same distance from a center. So if you had a center, you'd say, okay, these are all the things that are 1 centimeter away. But wait, I missed a few. I got to do more. I got to do more. I got to keep doing them all. All of those points that are the same distance on a plane. That's a circle. Are we just on a plane anymore? We're 3D, so what's a sphere? It's not a circle because a circle's only 2D. What's a sphere? It's not on a plane.
No. It's not a...
So what if I took a circle and also started counting distance going up? Would all these things up here still be the same distance from my center point as the stuff along there? Yeah. So the definition of a sphere is the same as a circle, but in 3D space. So it's all points equidistant from a center point in 3D space. Is a sphere solid or hollow?
hollow.
A sphere is hollow because the stuff that would fill it in, if you put whipped cream or something in there, they would be closer to the center than the sphere would be. Everything on a sphere is all the same distance. So imagine standing here with your hand, anybody you could hit all the way around you, or up and down from you, or over here, that all is part, that distance to your fingertip is all part of a sphere. This right here distance is not part of the sphere. It has to be all the way where you can actually smack someone. That would be a sphere. Don't go testing it out where I can see it. That would be bad. So a sphere is hollow. Shh. Okay? It's going to have a center, and that distance out that's the same everywhere is called your radius. So it is the distance to all points on the sphere from the center. So that distance could be here, it could be up there, it could be down here, it could be over there, could be anywhere. All these distances are all the same. They're all radii. So how do you define the diameter of a sphere then? Oh, but we do. We've got to torture teenagers.
Between two opposite radii?
How do you find the distance between them if they touch? There is no distance between them. Words are hard.
Yeah, they are. Never mind.
What do you think, Matthew?
The distance between 2 points that intercross through the center.
Yeah, and notice what he said. He said it's the distance between 2 points on the sphere through the center. So this is a diameter because it connects 2 opposite points on the circle through the center. Up here, this is 2 points on the sphere that aren't connected through the center. What is one of the most famous diameters on the Earth? No, the equator is something else. That's not a diameter either. The axis. That thing that it spins around that goes from pole to pole. Yeah. That is a diameter. Is it the only diameter? No. It will technically be the shortest on the Earth. Because is the Earth really a sphere? Is the Earth really a sphere? You student geography people that just took the test? We don't. Hi. So, yeah, there's 2 reasons why the Earth is not a sphere. One is because we have mountains. And so it's not all equidistant from the center. Everest is a lot farther from the center than the top of your head. Okay? But it's also not a sphere because it's spinning. And the centripetal forces of spinning cause the stuff in the middle to bulge a little bit, and the top smooshes down.
Oh, yeah, that makes sense.
So the Earth is technically a spheroid, which means something that's like a sphere but isn't.
Okay.
Okay?
Not sphere-ish.
Not sphere-ish, spheroid. Okay?
Yeah, too much.
And so, you can have diameters going, hi. So it's the distance between 2 points on sphere through the center. If it doesn't go through the center, it's not a diameter. Okay. So if you took a sphere, what if I took a sphere and remember how we did cross-sections before? What if I took a cross-section just right here at the very edge? What shape would it make? If I just crossed it just right here at the very edge. It'd make a small little circle, right? What if I cross-sectioned it about here? What shape would I make? A slightly bigger circle, kind of like the latitude lines. Okay. What if I cut it even further down? Would that be an even bigger circle? Where would I make the biggest cross-sectional circle?
The diameter, or the diameter.
At a diameter. And the biggest cross-sectional circle you make at the diameter is called the great circle. Okay? So it's the cross section of a sphere, and since if it's along the diameter, that contains a center. So ta-da, just like in that picture. And guess what a great circle cuts the sphere into? Hemispheres. See? If you have a big ball and you cut it down the center, you get a hemisphere. Either, I don't care. Okay. And this almost got me in trouble for cheating in 9th grade. Well, it didn't used to be geography in 9th grade. World history was in 9th grade. And so when I was in 9th grade, I was in world history, but we did a little bit of geography, and it's the start of the school year, and my teacher, Mrs. Jordan, is like, I'm just going to do random history and geography questions to see what people know. And I'm in like 4th or 5th or 6th period. And she goes in, and one of the questions is, what is the longest straight line distance around the Earth called?
There are many.
And, well, the equator is one of these.
But the prime meridian.
But what if I went this way? And so the longest straight line distance around the Earth is called the Great Circle Route, or the Great Circle Route. And so I wrote that down, and she was going through all the answers in front of everybody, and she was like, who got that one right? And I'm like, me? And I was the first person all day who got it right. She's like, how do you know that? Somebody told you that, didn't they? No? Well, then how would you know something like that? I took geometry and I read the encyclopedia. Please don't get mad at me. And she was like, what do you think, guys? They're like, yeah, she is totally like that. She would do that. And so she tried to bust me for cheating, but no, I just really knew that the Great Circle Route is the route along the Earth on a great circle. So all the meridians are great circles. The equator is a great circle. Are all the lines of latitude great circles?
No.
No, because they cross-section not through the center. They cross-section up here.
Yes.
And so they don't make a great circle. They just make a boring circle.
Like the line.
Shh. Okay? So, wait. So if I intersect a plane with a sphere and make a cross-section, what shape will it always be? Well, what if I cut it up here?
You cut it up there.
What shape will it make? If I take a cross-section of a sphere, what shape will it always make? It'll always make a circle. If you do it through the center, it's called a great circle. Ooh, fancy schmancy.
I actually do like that.
Okay? Shh. Now that we've done that, we go, okay, hemispheres are just what? Halves of a sphere?
Yes.
And this place, the surface where they touch, is the great circle. So they join at the great circle. So these two hemispheres here join right here at this great circle. Okay? Now that you know all the words, now you finally get to do a formula. What is surface area?
The area of the
It's the area of the surface. But is the surface of a sphere flat? No. So if we're trying to count the number of squares on a non-flat surface, is this going to go very well? No, it's not. So it's probably going to have something disgusting in it. The surface area of a sphere is actually 4 pi r squared. Do you notice anything interesting about that formula? What is pi r squared? It's the area of a circle. Shh. Guess which circle it's the area of? The great circle.
Oh.
So if you took, where did my great circles go?
I think.
Right here. So if you took this great circle from your sphere and made 4 of these circles, you could lay them and cover the whole ball. It would take exactly 4 of these. Now, it would wrinkle up, right? And so then you'd have to take the pieces that were too much and paste them somewhere else. But the area of this great circle, 4 of them exactly match the surface area of this sphere. And there's all sorts of fun proofs to say why. Do you want to do them?
No.
Good, because they take like 20 pages. Okay?
I didn't do like half of it.
What about volume? What's volume measure?
Cubes.
Oh, see, you're all doing it. This is why I was glad I should have done it, recorded it in R2 or in G5, because y'all are being loud. Okay, what does volume measure?
Cubes.
The cubes.
Cubes. But is a sphere flat?
No.
No, it's curved. So are there going to be a pretty number of cubes in this thing? No, there's going to be a lot of pi and crap in it. It's going to be, now, if it measures cubes, it's going to have pi r cubed in it. And it also has a 4 in it. But since we changed the 2 to a 3, we're going to divide it by a 3. Now it still has the 4 pi r squared, so the surface area is in there.
Nope, it's not square, it's cube.
I know, because if you did 4 pi r squared and then multiplied it by r over 3, guess what it becomes? So for some reason, the volume is always this much more than the surface area. And again, nature is weird. Why did it work out that way? I could show you, but then I'd have to kill you, or it would kill you on its own. So instead, you don't even have to memorize this. It's going to be written on the board. But I always remember it because it's the same as the surface area one, but you change the square to a cube, and then throw that same 3 on the bottom. So it's not too hard to remember those, but those are your formulas. Do you think using the formulas is going to be the hard part? Of course not. The hard part is going to be when we throw crap like this at you and say, please work it out. Shh. I want us to do 1 together. And if you will play along and do 1 with me, I will turn you loose to work on your homework. Sound fair? Okay. So I'm going to pick this 3rd one. So come down here to the 3rd example. Now, as you're looking at that, I'm going to show the instructions. The instructions say find the surface area and volume. So we need surface area and volume. And it says, shh, when possible, leave answers in terms of pi. Okay? Does this have circles? So do you think it's going to be in terms of pi? No. So in this case, I can round it to the nearest 100. Also on your homework, I think I said this earlier, if it says approximately equals to, then you can round to a decimal. If it says exactly equal to, that means terms of pi, or it means in radical form. Okay? So just watch for that on the assignment. So what shape do you have here? Classify this shape.
Pyramid.
It is a pyramid. See, it's got all the triangles coming up to an apex. What kind of pyramid? It is right. See how the height is perpendicular to the base.
With the square base.
Is it a square?
No.
It's not marked. So here's what I'm going to let you assume. See how I've told you that a base edge is 10? That means the edge of the base. If I only give you one of them, you can assume that they're all the same. Okay? We're going to say that this is a regular pyramid. Okay? What the heck is a lateral edge? These are these edges of the triangles going up to the apex. So that's all these edges along the triangles going up to your apex. Okay? So those are 15, and the base edges are 10. And that's all I give you. And you have to find surface area and volume. So you go, okay, well, what would be a good thing to start with writing down?
Formula.
The formula. I really, 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 really highly recommend that. So surface area formula is what? 1/2 perimeter times
Lateral.
slant height. Practice using the words in your head so they don't surprise you later. Okay? Don't get so lazy in your head that you don't know the words. Okay? Plus, that gives me all these side triangles, plus the area of the base. What about for volume?
1/3 base.
1/3 base times height, and that's area of base times height. So now you can pick. Which do you want to do first?
Surface area.
Surface area? Cool. So you start recopying it. I don't know surface area. Do I know what 1/2 is?
Yes.
Yes, it's 1/2. Do I know what my perimeter is?
Yes. 10 square.
No, not yet. Did they tell me perimeter? No, so I'm going to have to calculate it. So go off to the side and calculate your perimeter. How do you get perimeter of a square?
Adding up the side.
Adding up the four sides.
Perimeter.
So perimeter would be 4 times 10, which would be 40. See why you can't get all cocky? Okay. Do I have my slant height? No. Well, is it not the 15?
It's not.
No, that is one of these lateral edges. Slant height is perpendicular to the base edge. So it's this blue guy here. So we're going to have to calculate him. Oh dear. I know that slant height is perpendicular to the base of my triangle, and then this lateral edge runs like this. Oh, what shape have I made? A right triangle, and the slant height is running down the middle here. My lateral edge is being my hypotenuse. What about the bottom of this right triangle? Is it the whole 10?
No.
It's only going to be 5. It's a half side. Okay. How will I find my slant height?
Diagram theory.
Hello, Pythagoras! So my slant height squared plus 5 squared is going to equal the 15 squared. So my slant height squared plus 25 equals 225. So slant height squared equals what, 200? But I don't want slant height squared. I just want slant height.
Oh, you gotta.
I gotta square root it. So my slant height is going to equal the square root of 200. Now, on your homework, I would probably want this in radical form. So out of curiosity, what will this be in radical form?
14.
Well, isn't this 100 times 2?
Yeah, 10
So what's the root of 100? 10 root 2. So for now, I'm going to leave this in radical form, just to get the practice, because you guys, you've got to be fluent at this. You have to get good. And you're not going to get good if you keep getting lazy. Okay, you got to get good. And so I'm going to come over here now, and that's my slant height that I'm going to put right here in my formula.
And then now for the bases, we do.
And then I have to do plus area of the base. Do I know my area of base yet? Not yet. So I have to do the area of my base now. How do I get the area of a square? 10 squared, which will be 100. So I can come put that in now. But notice I did everything by hand. I didn't assume, I didn't jump to conclusions, I stopped and thought. Because it's when you start doing that knee-jerk crap that A, you end up kicking someone in the face, but B, then you end up doing something wrong because you're trying to go so fast that you don't think. Okay? Because your brain will give you all sorts of random crap unless you tell it, no, 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 stop and do the right stuff, and then it's like, oh, fine. Okay? So let's see, my surface area will then be, what's half of 40?
40.
Times 10? 200. So I've got 200 root 2. A lot of you on the test got stuff wrong because you halved the 40 and the 10. You don't distribute with multiplication. You just multiply. Half times 40 times 10 is 200. And then plus 100. This would be an exact answer, and it would be naked. What does it deserve? Meters squared. But if you wanted to round it to the nearest hundredth, you would put this in your calculator and get it to the nearest hundredth, which would be how much? Someone who has a calculator. Put 200 root 2. Bless you.
472.25.
Say again.
382.84.
382.84 square meters. Okay? Shh. On your homework, go ahead and leave it in exact terms, because most of the times it's going to ask you for exact. Only if you see the squiggle should you be doing the decimal. And make sure you do it to the right place. It said hundredth, so he gave me hundredth. Phew! Done with that problem. Now we got to do volume. Oh! But look! Volume is 1/3. Do I know big B? Yeah! You had already found that. Do I know H?
No, we can find it.
Oh. Did they tell me my height?
They did.
They did not. Shh! Look at your picture. Height is this vertical piece going down the middle. So I'm going to draw that right here. That's my height. It's perpendicular to the base. What is this apothem distance right here that goes out to the edge? It's, in this case, in a square, it's half the side, so that'll be 5. And then what is the hypotenuse of that triangle? It's your slant height. How big is your slant height?
10 root 2.
We already found it. It was 10 root 2. That's why I'm color coding everything, is so I can keep straight which thing went with which answer. See? Kidneys. So how am I going to find my height in this triangle? Special rights? Trig? Pythagorean theorem, because I've got 2 of them. So I could do h squared plus the 5 squared equals 10 root 2 squared. And at least half of you got problems wrong because you squared a radical wrong. So careful. How do you square 10 root 2? You square the 10 and get 100, and you have to square the root 2. What's root 2 times root 2?
2.
It's root 4, which is 2. And so that equals 200. So h squared plus the 25 equals 200. So I'm going to bring this over here because I ran out of room. So my h squared will now equal 200, take away the 25, which is 175. And so my h by itself will be whatever the square root of 175 is. What's that, 5 root 7?
Yeah.
Because that's 25 times 7. And so, right, 25 times 7? So it'd be 5 root 7. And so that's what would go in for your height, in your volume form. You see how everything is all here, and any extra work I needed to do, I went out of the way so I could go back and have my algebra stay nice and tidy. Good strategy for next year and the year after and the year after and the year after. Okay? So now you go, okay, so my volume is going to be, now how do I multiply with this fraction? Because 100 doesn't divide by 3 and 5 doesn't divide by 3. Go across the top, go across the bottom. So what's 1 times 100? What's 1 times 100? 100 times the 5. It's 500, and then the root 7. Go on the bottom. What's 3 times the 1?
3.
3. So 500 root 7 over 3. That fraction doesn't simplify, so you could just leave it like this, and then what would the units be if it's volume? Meters cubed. If you wanted to turn it into a decimal, then you would get your calculator out and get whatever that comes out to be. Yeah.
440.96 if you're on the
0.96 if you were rounding it. And so if you had an approximate, you could have that. Get comfortable working with fractions in your, not irrational, in proper form. Okay, yeah.
On the test, how many questions are going to be like this long?
Several. That's the thing though, is all of this stuff is old stuff. So doing the Pythagorean theorem, should it take you as long to do it on your own as it did for me talking to everybody? No, you should be good at Pythagorean theorem. Should you be pretty good at squaring radicals by now? Should you be good at using special rights? Yes. Should you be good at working with radicals within this? Yes. So it's going to take some time, but the point is by now you should be fluent. If you are not, don't go to honors next year. Save yourself. Because they start off expecting you to be good at this. So, yeah. All right? So you now have the remainder of our period to work through your homework.